So as I mentioned earlier, I'm going to do a video using this hot water tank and go over a number of the different aspects of this hot water tank and a few other things. Need to thank Gravenhurst Plumbing for the hot water tank. I was able to get that from them. My old friend Mike. Mike and I go way back. Mike used to be a manager of a grocery store that I looked after, so I've got some history, and Mike will attest to the fact that neither one of us is really any older. We're just very much smarter than we used to be. So anyways, thanks Mike, thanks Gravenhurst Plumbing for the tank. And again, we'll go over some things with this tank and hopefully learn some things. So the first thing we're going to do as we walk up to this tank is have a look at it. We'll notice that it's a Superflu 50. I'll tell you why in a little bit. You're going to see the nameplate here. So lots of information on the nameplate. Got the model number here. It actually tells us here that this is propane. So this hot water tank was used with propane fuel. 34,000 BTUs, the capacity. Clearances, a lot of information there. It actually tells you venting type to use. We'll talk about the S636 venting in the next video, I think. So lots of information there. Wiring diagram, which really isn't in that great condition, but if I was troubleshooting, I would probably be looking at that to get some information that I would need. We'll look at the burner in a little more detail later. There's the burner there. We're actually going to pull this burner out. So look after that. Look. The other thing we're going to notice on this tank is it is power vented, so it has a venter motor on top. There's the cold water connection, and then over on this side you'll see the hot connection on the top. The other thing we see up on top here, I've opened up this electrical compartment, and back in here, let me pull some of these wires out. Back in here there is a pressure switch. It appears that the tubing is missing. There's a connection on the back that the tubing connects to, and then it comes around and connects to a little port here. Basically senses whether this venter motor is operating or not, and if the motor is not operating, the hot water tank will not operate. The burner will not fire, so it's a safety control. So also on the outside of this tank is the temperature pressure relief valve, TP relief valve. You can see that there's a little hose there, extends down to the bottom, which if you look in your code book, that's actually required by code. So temperature pressure relief, and if we look really close here, you'll see that it is 210 degrees, 150 PSI. It's upside down, but hopefully you can read that. So it will relieve based on temperature or pressure, and I'll show you the inside a little bit later. So we're gonna focus on the burner here right now. So cover here, this cover comes off pretty easily. Just set that aside. Not often on these tanks you're going to take the burner out. It's not going to happen. So gas line, this is the gas line here, this silver pipe. Because this is a power vent, a little bit higher efficiency. This is a little bit different, and you'll see why in a second. I'm just going to loosen this pipe. And then there's a few wire connections. It's all quick connects, so it's fairly easy to take apart. Easier said than done. That shouldn't be too bad. There we go. So these wiring strips, just pull them apart, pull that one apart. These just pull out of the gas valve pretty easily, and all the wiring's out of the way. There is there are two black wires here, and there we go. Just had to adjust that a little bit. They actually go underneath here and over to the side here. There is what's called a flammable vapor sensor. So if you were to store a can of gasoline beside your hot water tank, because the vapors are heavy and they can get sucked into this burner compartment, this would sense that and it would shut your burner system down. So it's a safety control. Okay, so my pipe is disconnected, my wires are disconnected. There's usually 2 screws here. I've already taken the screws out earlier. This whole assembly will now pull out. Bit of a tight fit, and there you see the burner right here. All the way around is the burner. Because this is power vent, it's a little higher efficiency, hot surface igniter, flame sensor. If this was an atmospheric burner, a standard non-power vented hot water tank, this would be a standing pilot. So there would be pilot tubing, there would be thermocouple. The pilot would be running all the time. This particular one, the burner lights every time there's a call for water to be heated. So that's a little bit of the difference between these two. Pretty straightforward. This, a lot of the literature that I've read, they call this an under-fired burner. I don't like that term. I call it under-fired because it's underneath and it fires up. In the realm of gas appliances, under-fired tends to have a whole different connotation. So I don't like the term under-fired. Yes, it's underneath. I've heard it sometimes called upshot, a few different things, but it does heat underneath, heats the water, and then we'll see inside in a little bit. There's a tube that goes up the center. So that's the burner assembly. Pretty easy to take out, although not something you're gonna do a whole lot of, and pretty easy to put it back together. So that's the burner. So the last and final thing I wanted to show you, we're going to go around the back here, and you'll notice, oh look, there's a big hole in the back of my hot water tank. But I did that on purpose, so you can see inside. Just going to move the light here a little bit, shine some light on the inside so you can see really well. So there you go, that's the inside of the hot water tank. This right here is the anode, the sacrificial anode. You can see how much buildup there is on there. So it's doing its job. It basically takes any corrosion attaches to that to steal it from start corroding anywhere else. These tanks are glass lined, but you know, it is what it is. This tube here down the center, that's the burner tube. So the flue gases go up through the center and up to the fan up on top. Here is the dip tube, the tube that goes down to the bottom. The cold water in goes from the top down to the bottom. You can see the 2 holes that I showed earlier, the cold water hole, the cold water fill hole, the hot water out hole over there. Anode, yes, it is replaceable. You can actually take these out and replace them. Generally, the tank is just replaced. Over here, you see the sensor for the temperature pressure relief. So that would be the temperature part of it, the probe. And down here further, you can see the probe for the gas valve, sensing the temperature of the gas valve. Also, you will notice in the bottom a lot of crud, a lot of sediment. So that's all buildup from the water. That all comes out of the water. This lime scale calcium comes out of the water, builds up in the bottom of the tank. It's natural. Obviously, as this builds up, the efficiency of my tank is going to go down because now I'm insulating from the burner compartment. So the heat that comes from the burner compartment is going to be robbed because of all this crud that's building up in the bottom. So that's kind of the downfall of hot water tanks, is the buildup of calcium scale and all this sediment that's in the bottom. So one sort of final piece to the equation with hot water tanks, you'll see on the gas valve here, if you noticed earlier, there's some temperature settings, hotter, colder. In the question, what is a good temperature setting for my hot water? So if you read some literature, read the gas code books and the other safety literature, plumbing code, things like that. For safety consideration, 120 degrees Fahrenheit. Let me just have a look here. 45 degrees Celsius, 120 degrees Fahrenheit is kind of what they say is the safe temperature setting. Any higher than that, then you can really have some serious injury from scalding for children, old people, elderly people. Anybody really, if you're exposed to water temperatures higher than that for any length of time, you can get second and third degree burns very easily. The problem is there's a thing called Legionnaire's disease, the bacteria, and you Google it, and there's a lot of information happens in cooling towers as well. Bacteria can grow inside your tank, and you need to have at least 140 degrees in your tank, 60 degrees Celsius, in order to kill that bacteria. You go, okay, now, so what do I do? They're saying 120 degrees, and they're saying 140 degrees. Which one should I use? So what they've done is you can get a mixing valve. So what the code says to do now is to put a mixing valve on top of your tank. And if you're in my lab, I've attached some documents to the E-Centennial shell, the manual, the installation manual for this tank, and it actually, there's some diagrams in there. There's a diagram with the mixing valve on top. So what you do is you set the tank for 140 degrees, but your mixing valve on top of the tank is set for 120 degrees. So at least you're maintaining the 140 degrees inside the tank, and you're not getting that buildup of bacteria inside the tank, and that is how they alleviate that. So if you see a valve on top of the tank, that's what the valve does. Very common now. I believe it's actually part of the plumbing code to have that now, or building code, I'm not sure which. So that's sort of the temperature story as to what your temperature setting should be. So hopefully this video has answered some of your questions about hot water tanks. And hopefully do one more video with a few peripheral things. The last video I want to do, we'll probably look at some 636 piping. We'll look at thermocouples, thermopiles, and a hot surface igniter. Hopefully, heat up some of the sensors and show some voltage readings, and connect the wire to the hot surface igniter. Actually show it work. So that'll be the final video coming up shortly. So look forward to that.